Title is Design, Development and Performance Analysis of Multitask Multi-Tank Water Level Controller with Automated Power Supply for Multi-Store Buildings. The project solves three major issues. One is the water level monitoring control in the different tanks using LCD display. The second issue is automatic switching on and off of the motor when the water reaches the high level. The third major issue is it depicts the different water levels in the tank and if it switches off automatically if alternative valves are on simultaneously.
Now let us see the connection of our proposed model. Our project wiring and connection starts with the AC supply, which connects three individual electric meters to the respective contactors. A common point from a contactor is given to the AC motor. Another common input terminal from the contactor is sent to an auxiliary 12-volt transformer. One of the output of a transformer is connected to the Arduino through bridge rectifier. Another output is connected to the PIC microcontroller, which consists of inbuilt bridge rectifier. Arduino expansion adapter set consists of three interlinked connections to the Arduino pins. The connection to the Arduino analog pin comes from roller micro switch, and the second connection from the digital pin of Arduino is connected to the 5-volt DC relay, and third is connection with the I2C interface LCD display. The output of relays are given to the respective PIC microcontroller. Water level sensor in the overhead tanks are connected to the input of a PIC microcontroller. The output is sent to the another set of auxiliary 5-volt DC relay. Further, the output of relays are connected to the input of a contactor.
Let's see the proposed methodology. The first step of the methodology begins with opening up the valve. The valve is isolatedly connected to the roller micro switch, which sends the position of the valve and analog signal sent to the Arduino. As Arduino is connected with I2C LCD, which displays which valve is on respective meter billing and tank loading, the monitoring and controlling action of the Arduino sends its digital output signal to the respective relay for tripping action. Once the relay gets tripped, the respective microcontroller gets activated. Based on the water level in the overhead tanks, microcontroller sends a signal to the respective auxiliary relay for tripping action. Once the relay gets tripped, the respective contractor will contract, which is switch on the motor. The electricity bill is obtained only from the respective meter.
Now let's see the different scenario of our working project. Now let us see the different scenario. Let us consider a building with tank A, B, C, which is connected to the valve A, B and C. Now if the valve A is made on, we can see the status that valve 1 is on, meter 1 and tank 1 is loading. But the motor will not start because the tank is full. Now simultaneously valve 1 is on whereas valve 2 is made on, then it shows the status that invalid choice, check the valve status. Then we have to make the valve 1 should be off. This shows that valve 2 is on, meter 2 is on and tank 2 is loading, which makes the motor on and the tank 2 is filling. Hence there is no water present in the tank 2, which is showing the dry status in the LEDs. If valve 2 is on, simultaneously valve 3 is made on, then we can see that it shows the status that invalid choice, check valve status. In this condition, we should make the valve 2 should be off. Then it starts the valve 3, meter 3 and tank 3 loading status. That leads to filling the tank 3. If all the valves are on, then it shows the invalid choice, check valve status. If all the valves are in off state, then it shows valve, meter and tank status.
Result and conclusion of the proposed model. As per the tests and experiments conducted on our proposed model, we have obtained some major results. The first result obtained is the motor switches on only if one of the valve is open. If either of the valve is open together or all the three valves are open, then the LCD display shows that the invalid choice and doesn't on the motor. The second result obtained is if the water reaches the top level in the tank, then the motor switches off automatically to avoid overflow of the water from the tank. The other result obtained and the last result, that is the major objective of a proposed model, is the separative individual billing for the respective meters when the motor is switched on for the respective tank filling. Conclusion of the proposed model. The multi-tank water level controller for multi-store buildings with a single motor has been successfully installed at DC Energy Park. The set objectives were successfully obtained and checked through the tests and experiments conducted on the demo model.